Welcome everyone to GalaxySpaceTalk. On today's podcast, we'll be diving into an interesting conversation, and it's all about time dilation. Join me, Nanekia JC, as we delve into this exciting topic. With me is my guest,
Charles Darcy, mission engineer.
So, Monagbeli, I'm currently a student at Presbyterian Boys Secondary School, Legon.
Can you please tell us a bit about yourself, your ambitions, and what you intend doing?
Alright, so personally, I'm someone who loves everything space or everything astronomy, and I'm hoping if everything goes well that in the future I can become an astronaut.
Okay, becoming an astronaut. Okay, hopefully he will be our first astronaut, and we are hoping for that. Thank you for joining us for
All right.
today's podcast. Mr. Charles, can you also tell us a bit about yourself?
Okay, I think so. I'm Charles. I'm with Galaxy Aerospace as the mission engineer, handling a few projects that is supposed to gear us towards getting to space by 2030. So it's an exciting time to be here to also share some of the knowledge that we have acquired over the period with Galaxy to the whole public to learn more into the space realms.
With our topic, time dilation, I mean, people are already concerned about time. I mean, when you say time, people come up with so many explanations for time. And now we're adding dilation to it. So, what is time dilation?
When we talk about time dilation, we are basically talking about the differences in time for an observer between two reference points. That's how I can put it. Basically, what we are trying to say is that depending on special factors, the way time flows for me might differ from the way time flows from someone else. So that's what is time dilation. How time flows depending on those factors that we'll get to later.
Okay. All right. Mr. Charles, you can come in.
Yeah, I think to the layman, it means the difference in time with regards to conditions, as Solomon said, that we are going to delve into. So to a layman, it is how an observer records his time as with regards to another observer recording the time. There might be a bit of differences. That is why the name is time dilation.
Okay, so talking about a bit of differences, is there a difference between time differences and time dilation?
Yes, there's actually a huge difference between time difference and time dilation. So time difference deals with geographical location, meaning depending on where you are on the planet at the moment, your time might differ from my time. That's why it can be 3 o'clock here, maybe 6 o'clock in America. That's why we talk about time difference. But when we come to time dilation, it means that my time dilation deals with it there says that my time might move way faster than your time. Meaning, if you were to put it in ratio from 1 second of my time could maybe approximate to like 4 or 5 years of your time, depending on how fast I'm moving. That's time dilation, to put it simply.
Yeah, I think as you said, depending on your speed or depending on how fast you approach the speed of light, that is when you're able to experience the real time dilation. You're able to see it clearly that, okay, your time has slowed down comparatively to an observer. So that's what he said. Your 4 seconds can be 15 years for somebody who is probably in a certain situation that is either gravitational or either at high speeds that is very close to the speed of light.
Okay, so time dilation talks about velocity, as you said. So if I'm getting you, my 5 days here can be someone's 5 years.
Yes.
When it comes to time dilation.
Yeah.
But time difference talks about geographical area.
Yes.
So I'm in Ghana, and my time here is different from someone in South Africa or USA.
Yeah.
So that's the difference between time dilation. Okay.
Yes.
But how does time dilation occur?
It's as simple as this. There are 2 laws of relativity that Einstein postulated. And that is what has led to how we could arrive at time dilation. He said the laws of physics work for anybody from a referential or inertial reference point. That was his first postulate. And his second postulate is the speed of light is constant for anyone in anywhere. So when you're in space, when you're on Earth, wherever you are, the speed of a photon of light is the same, which is 300,000 kilometers per second. Okay, so you can imagine traveling at those speeds at 300,000 kilometers per second. How would you measure someone's time who is running at 300,000 kilometers per second? Can you imagine? Within 1 second, he's done 300,000 kilometers. You understand? So his time begins to slow down because in his initial reference point, if he's in a spacecraft that is traveling at that speed, and an observer is watching him, he in the spaceship will check his time. His time is okay, it's moving for him. But for an observer, because he's moving too fast, he can't even measure his time. So time will slow down for the observer.
Okay. All right. So, how does time dilation occur?
So it's basically the faster you move, the slower time goes for you. That's the basic principle behind time dilation. But it's based on observation or your observation reference point. As said earlier, for someone moving close to the speed of light, time appears to move normally. But from someone who is outside that velocity or who is moving at a slower velocity, you will see that to you, the person observing, you see that the person moving at the speed of light has started to slow down. To put it in reference, let's say an astronaut was to spend maybe 3 years in space, moving close to the speed of light. That 3 years, he might come back to Earth to find out maybe 100 years have passed or maybe 200 years have passed because he was moving so fast. The time on Earth started to speed up, or that's what he'd see from his reference point. And to your point, he has started to slow down.
Okay.
And that's because, as I said, the distance he's covering. You can't even measure the time and the distance because when you look at the time, before you even be able to, per se, take your watch to measure the time, he has already covered so much distance. So he starts to slow down. Or whatever is going around or whatever is traveling at that speed starts to slow down compared to you. That's how time dilation works.
Okay. So, time dilation, does it occur on Earth?
Time dilation or does occur on Earth, but it occurs so tiny, it occurs so small that we can't really observe it. I mean, technically, the faster you move, you can even have a difference between maybe the watch in a train moving at 100 kilometers per hour and the watch of someone standing slowly. But because the difference is so small, you hardly notice.
So, someone in space and someone on Earth, they are moving at different time, speed of light, right? Okay. So, an astronaut, I just want to buttress on the point you made. An astronaut in space he thinks he has spent 5 years in space, but comes on Earth and realizes that, oh, it's already 50 years. Is that what you mean by
Yes,
how
that's a
time?
possible solution. But the only way it could happen like that is if the astronaut was moving close to the speed of light.
Okay.
Because the slower you are, the less the time dilation occurs. So the difference between your time and my time becomes fewer. So if, let's say, the astronaut you're talking about was moving at maybe 99% the speed of light for those 5 years, it is possible that he could come back to Earth and find that maybe 50 years have passed or 100 years have gone by. But let's say he was moving like maybe 2% the speed of light. Moving at 2% the speed of light, he might come to see that time might have gone faster than he thought, but
Okay.
it won't really be noticeable.
Okay. Can we do anything to prevent the impact of time dilation?
Not really, as I said, on Earth, because it's very, very small and insignificant. It will definitely happen, right? There's nothing that can be done. There was an experiment that was carried out in the 90s by one Hafel Keaton. He actually put a watch on a plane and he stood there with his own watch. And the plane did a few revolutions around the Earth a few times. When they came back, they realized the time had slowed down for the plane, but it was in nanoseconds.
Okay.
So that was one of the main experiments that proved that time dilates when you are at some high velocities,
Okay.
basically. So there's nothing that can be done. It occurs.
All right.
And so, as you said, that's also another experiment that has been carried out, or the theoretical mind experiments that I mentioned earlier. The slower you are, the less the difference in the time. So time dilation cannot be prevented because we always have a body that is traveling at a high velocity, meaning time always moves slower. But most of the time, it is so insignificant that you can just ignore it.
So insignificant. So that means we can't observe time dilation in our everyday life.
No, it's not possible to observe time dilation in our everyday lives. It's there, but you can't observe it like with the normal human eye.
Okay. Okay. Please, do you have anything to add?
Yeah, I think that's true. It's quite minimal, so it's we don't usually consider it, but it happens. Yeah, so it's quite insignificant, as he said, and it's not easy to observe unless the person is moving at top speed, close to the speed of light. That is when you can observe it.
All right. But people will be wondering, speed. We've been talking about speed of light, and we are talking about time dilation. What's the difference between the two?
There isn't really. We can use the definitions to differentiate them, as in the speed of light being a certain amount, that's 300,000 kilometers per second, as a photon of light traveling at that speed. Now, time dilation only occurs as a result of that phenomenon light has. The fact that light has a constant velocity. It doesn't accelerate. It doesn't decelerate. It is 300,000 kilometers, and that is per second, and that is all. Yes, it doesn't like it goes 302,000, 298,000. So that relation just helps us to effectively detect that when you travel at the speed of light, which is constant, your time dilates, your time slows down.
The speed of light is often described as scientists as the speed limit of the universe. It's constant, as earlier said, it doesn't change. It's forever 300,000 kilometers per second. And because it's so fast, that's why we use it in time dilation. At those speeds, that's when the effects of time dilation actually become visible. So that's why mostly when we talk about time dilation, you see a reference to the speed of light, because that's when you can actually observe the effect of time dilation. Anything that is not moving close to the speed of light, time dilation becomes insignificant for it.
So, with this said, what's the role of time dilation in the concept of time travel?
Alright, so the concept of time travel is basically being able to manipulate time in such a way that you can either move forward in time or backward in time. And if we look at it from what we've been saying so far, we can see that if we're able to dilate time enough, we could actually travel into the future. However, in practicality, because we've not yet discovered a way to travel at close to the speed of light, it's not possible. Time travel is not possible. But if we were able to travel fast or faster than the speed of light, which is impossible physically, we would be able to dilate time enough to possibly travel to the future.
Okay, so time travel talks about moving into the future.
Not only into the future, but also into the past.
Okay.
So time dilation, well, what happens with time dilation is because your time slows down, the rest of the universe time continues. So you will only be able to move into the future if you use time dilation. I'm not sure about going back into the past when it comes to time travel.
Okay. So
Yeah, I think he's said most of it, as in, whilst time slows down for you, that's why you can go into the future. So you come back at the age of 15 years and someone is 60. So you've come back into the future because you left Earth when we were both 15 years, traveled at the speed of light for 6 months. And when you came back, you realized that somebody you stood there with who was 15 years is now 45, but you're still probably 16 years. So that means you have traveled into the future. You've elapsed that whole time into the future. So that is the only way, as he explained, that time dilation works.
how does time dilation affect the aging of space travel?
Yes, as we earlier explained, once you are moving at top speeds, and obviously once you are in space, you don't have air resistance, so you are always at top speeds. You are always moving at top speeds. So when you escape from the atmosphere and get into space, probably traveling at maybe 40,000 kilometers per hour, Remember, once you get into space, there's no resistance. So you are just traveling at the same speed all the time. So definitely astronauts will age lesser a bit if they are in space traveling than someone who is on Earth. I think there was an experiment between two twins, and I think one stayed at space for long. When they came, I think the heights had been different. There was a bit of, they looked up till he stayed a bit down. But that was, okay, mostly used to the fact that there was a bit of stretching and all that. So there are little changes, especially when it comes to speed of light. It really affects, or approaching that speed, it really affects our aging and the aging of space-time.
All right. Okay. Do you have anything?
So as I said earlier, the faster you move, the slower you age. So astronauts moving at a constant speed in space will definitely age a tiny bit slower than normal human beings who are here on Earth. That's how it affects travel in space.
Okay. And does it affect particles in space too?
Yes, it does affect particles, because what we learn from all of observes that particles take a certain time and then decay. So because they decay in a certain period of time, the faster they move, the slower time moves for them, meaning that it will take a particle longer to decay than originally it would have. So time dilation also affects particles in space.
Is there anything you want to add up to the topic time dilation?
Okay, I think I would doff my hat off for Einstein for being able to discover something like that in his time without any technology, without any help from any computer. And the fact that today time dilation plays a very, very important role in our daily lives and how it affects some of the things we do. And it has given us a better insight into how even we are supposed to set clocks in space to work as a result of probably gravity as you move away from Earth. So time dilation has helped us in a lot of applications in going forward. So it's a brilliant idea by Einstein, and I doff my hat for him.
All right.
So what I'd like to add about time dilation is that so far we've talked about time dilation being as an effect of velocity. However, there's another form or way through which time dilation works. That's gravity. The closer you are to a gravitational source, the slower time moves for you, which also explains why an astronaut in space would age slower than a human being on Earth, because we are closer to Earth, which is a point or a source of gravity. So we'd age slower plus the velocity of the astronaut. So time dilation also occurs due to difference in gravity within areas. And it also explains why, if in theory someone was to fall into a black hole, the person would appear to stop. Meanwhile, the rest of the universe will appear to speed up because the black hole has more gravity, meaning time dilation would occur. It's one of the instances where gravity can cause a huge effect or a visible effect of time dilation. So yeah, Einstein did very well being able to theorize all this in his time when he didn't have all the technological advancements we had today.
Thank you, Solomon and Charles, for joining us for today's podcast. I have learned something about time dilation, and I know you at home have also learned something. Till we meet again for our next podcast. Don't forget to follow us on all our social media channels for more interesting podcasts. This is GalaxySpaceTalk.